Hello everyone! I hope you're still with me because in this episode we'll discuss an interesting concept called function interposing. If you're already familiar with Linux OS, you might already know about or maybe used before the LD preload environment variable. This instructs the loader to load a custom library. Why is this useful? Let's see. The functions from our library will take precedence over the same functions defined in the other libraries linked to the applications. Pretty neat. This behavior is very useful for testing purposes, but it can also be abused in some exploitation scenarios. Let's look at replicating this trick on macOS. Alright, for this I have two very simple applications. The first one will generate a list of random numbers. First, it will initialize the seed of the random number generator based on the timestamp, then generate pseudo-random numbers and print them. Very simple. Let's see. Compile and run. Okay, we get 10 random numbers, nothing fancy. Before introducing the function interposing technique, we also need to discuss a bit about the two-level namespace concept. Compared to Linux self-binaries, macOS binaries use two-level namespaces when resolving symbol names. In simple terms, this means that to resolve an external symbol, the namespace on the first level is represented by the object name, and on the second level are the symbols from that specific object itself. This technique has a few benefits. For example, the symbol resolutions are performed much faster. And we can also have symbols with the same name in different namespaces. Now that we know about this concept, we have to be aware that there's an option to compile flat namespace binaries using a specific parameter. Don't worry, we'll see where all this is needed in a minute. Let's go ahead and recompile our small app, but now with the force flat namespace flag. The behavior should be the same. We still get the 10 random numbers. All good so far. To do the function interposing trick, we need to create a custom library and force the program somehow to use the functions from our library instead. We have a couple of options to do that. The first one is to use an environment variable which behaves similarly to LD preload. The variable is called dyld insert libraries, and its value should be a list of libraries to be loaded, which will have priority over the other libraries. Basically, it will allow us to override symbols from system libraries with functions from our custom dynamic library. As you can see here, I have redefined the rand function, which is used in the first app we've written. The redefined behavior will always return the not random at all number 42. Let's compile the library. I have already prepared and saved the commands here in the comments. We'll fix the error by simply using the full path to clang. The command should generate a 64-bit dynamic library with .dylib extension, which we can check using file command. To test it, we'll also recompile the initial application because we've messed around with the flat namespace flags, remember, right? In this case, we'll generate two binaries. The first one will be compiled as usual with a two-level namespace. Then we'll generate another executable with a flat namespace and we'll change its name to include the suffix flat. Okay, so we have both files named as such. Great so far. Let's see next the function interposing trick in action. First, for the binary with a two-level namespace, for this case, we'll need to add another environment flag, dyld force flat namespace. Very self-explanatory name, it will force a flat namespace on the binary. If we didn't use this flag, dyld insert libraries would not be effective at all according to the man page. Let's see. Look at that! We've overridden the rand function and now it always generates the number 42. You can probably imagine the security implications of being in a position to do a trick like this. You could alter the behavior of a larger application with serious implications. Most probably, this would also be very hard to detect because random numbers are used as a starting point for more advanced calculations. We could also achieve this behavior without the flag that forces a flat namespace, but using the second binary we generated that already has a flat namespace. It should work in the same way, and if we didn't make any mistake, we should get the same results. Great! Keep in mind there are also some limitations when using this method. For example, we cannot abuse SUID binaries with this trick. But still, I believe this is a very interesting technique to know about. I hope you like this technique and that this episode will motivate you to do more research on your own. Thank you very much for watching and hope to see you in the next episodes. Don't forget to subscribe and hit the like button. Cheers!